For the past few years, it has felt like the systems around us keep breaking at exactly the wrong time. A software update crashes millions of machines. A cloud region goes dark. A network outage cuts people off from emergency services. An airline scheduling system collapses under pressure. A single configuration mistake takes down services people rely on every day. And every time it happens, we ask the same question. How does this still happen? Because this is not a world without talent. We have brilliant engineers. We have better tools than ever. We have more cloud capacity, more automation, more monitoring, more security, more data. And yet, things still break. Now imagine something different. Not perfect infrastructure. Perfect is not real. But infrastructure where failures are expected, contained, and recovered from before most people even notice. A cloud outage that does not become a business outage. A bad deployment that rolls itself back in seconds. A security incident that stays isolated instead of spreading. A system that knows how to bend without breaking. That future is not science fiction. It is not guaranteed either. It is a choice. And this season has been about the pieces of that choice. Multi-cloud, chaos engineering, distributed systems, self-healing infrastructure, infrastructure as code, maintenance excellence, open source, effective regulation, and the economics of resilience. So for the Season 3 finale, we are going to do something a little different. We are going to look ahead. What could infrastructure look like in 2050 if we actually learn the lessons we keep paying for? Welcome to the Season 3 finale of The Breakdown Economy. I'm Tony. Usually on this show, we start with something that went wrong, a failure, a collapse, a missed warning sign, a system that was more fragile than people realized. But today, I want to start with a different question. What does it look like when infrastructure goes right? Not once, not during a demo, not in a press release. I mean every day, quietly, reliably, in the background. Because that is the strange thing about good infrastructure. When it works, most people never think about it. Imagine it is 2050. You wake up, your home systems sync, your calendar updates, your devices connect, your car, train, or transit app checks routes, your banking app works, your work tools load instantly. Nothing feels dramatic, and that is the point. Behind the scenes, the request from your device may not be going to one cloud, one data center, or one server. It may be routed through a resilient mesh of systems, multiple regions, multiple providers, edge nodes closer to where you are, automated failover, encrypted connections, real-time health checks. But you do not see any of that. You just see the app open. That is what infrastructure excellence feels like to the average person. It feels boring. And boring in infrastructure is beautiful. Now let's say one cloud region has a problem. In today's world, that can trigger headlines. In a better 2050, it triggers a reroute. Traffic shifts. Workloads move. Data stays consistent. Users barely notice. Not because nothing failed. Something did fail. But the system was designed around the assumption that failure would happen. That is the real shift. The future of infrastructure is not about pretending systems will never break. It is about building systems that know what to do when they do. If infrastructure in 2050 works better, it will not be because one company owns the perfect platform. It will be because the foundation became more open, more portable, and more distributed. That starts with open source. Linux, Kubernetes, containers, open standards, shared tooling. We talked about this earlier in the season. Open source matters because it creates a foundation that everyone can inspect, improve, and build on. No single vendor controls the entire road. No single company gets to decide what the future of infrastructure must look like. No customer has to trust a black box forever. That does not mean open source solves everything. It still needs funding, governance, security, maintainers. documentation, accountability. But it gives the world something proprietary systems often do not: a shared foundation. Then comes distribution, no single point of failure. That phrase gets used a lot, but in 2050, it has to become more than a slogan. It means applications are designed to survive regional failures. Data is replicated intelligently. Systems use consensus where consistency matters. Traffic can move around damage. Services degrade gracefully instead of collapsing completely. And this is important. Resilience does not mean everything keeps working perfectly. Sometimes the best system says, this feature is temporarily limited, but the core service is still available. That is not failure. That is controlled degradation. And controlled degradation is far better than total collapse. The mature version of infrastructure does not pretend it can avoid every problem. It knows which functions matter most. It protects them first. One of the biggest changes between today and a better 2050 is how much recovery becomes automatic. Today, too many failures still depend on humans noticing the problem, joining a bridge call, finding the owner, searching dashboards, reading logs, debating what changed, and manually rolling something back. That is stressful. It is also slow. In a more resilient future, the first response is built into the system. A container crashes. It restarts. A node fails. Workloads move. A deployment causes errors. It rolls back. A route becomes unstable. Traffic shifts. A dependency degrades. The application changes behavior. Humans are still involved, but they are not the first line of defense for every small failure. The system handles the predictable problems. The humans investigate the deeper ones. That is a better use of talent. Instead of spending all night trying to restore service, engineers can ask better questions the next morning. Why did this happen? Why did the system respond that way? How do we prevent this class of failure next time? Where else could the same weakness exist? That is how infrastructure improves, not by heroics, by learning. And this is where chaos engineering fits in. By 2050, mature companies do not wait for reality to test them. They test themselves. They simulate outages. They kill services in controlled ways. They test backups. They test failover. They test human response. They test assumptions. Because the first time you learn how your system fails should not be during a real emergency. Now, we cannot talk about 2050 without talking about AI. By then, AI will probably be deeply embedded in infrastructure operations. Predicting failures, detecting anomalies, recommending rollbacks, optimizing traffic, spotting security patterns, helping teams understand complex systems faster. That sounds powerful. And it is. But we should be careful not to turn AI into magic. AI will not eliminate infrastructure failure. It may reduce some failures. It may speed up recovery. It may catch patterns humans miss. But it can also introduce new risks: bad recommendations, over-automation, model drift, false confidence, systems that are so complex nobody understands why the AI made a decision. So the future cannot simply be let AI run everything. The better future is use AI to help people see more clearly. Use AI to detect weak signals. Use AI to summarize incidents. Use AI to simulate outcomes. Use AI to reduce toil, but keep human accountability. Because infrastructure is not just a technical system. It is a social system. People design it. People fund it. People regulate it. People depend on it. The best 2050 is not humans versus automation. It is humans with better tools. Here is the part that does not fit neatly into a dashboard. The future of infrastructure depends as much on culture as it does on technology, because the tools already exist for many of the things we have discussed this season. Multi-cloud exists. Kubernetes exists. Infrastructure as code exists. Chaos engineering exists. Monitoring exists. Open source exists. So why do companies still fail? Because tools do not fix incentives. Tools do not fix leadership. Tools do not fix a culture that rewards speed but ignores risk. In a better 2050, reliability is not treated as something you add later. It is part of the product from the beginning. When a team proposes a new feature, they also answer, how does this fail? How do we detect failure? How do we recover? What happens if traffic doubles? What happens if a dependency goes down? What happens if the deployment is bad? What is the customer impact if this breaks? That does not kill innovation. It protects innovation. Because a feature that cannot survive real-world conditions is not finished. It is just launched. And that is a major cultural shift. From move fast and clean it up later, to move thoughtfully and build things that last. Another cultural shift is how teams handle failure. In fragile organizations, failure creates blame. Who pushed the change? Who approved it? Who missed the alert? In resilient organizations, failure creates learning. What made this possible? Why did the system allow it? What signal did we miss? How do we make this harder to repeat? That is not being soft. That is being serious. Because blame may satisfy emotion, but learning improves systems. Now let's talk about the piece that decides whether this future actually gets built. Money. Because infrastructure teams can know the right thing to do. Engineers can warn about risk. Architects can design better systems. But if the business refuses to fund resilience, the future does not happen. This is why Episode 9 mattered. Reliability has to be framed as an investment, not just an IT expense, because downtime is expensive. Customer churn is expensive. Regulatory scrutiny is expensive. Reputation damage is expensive. Emergency recovery is expensive. Prevention may look costly in a budget meeting, but disaster is usually more expensive afterward. The companies that build better infrastructure by 2050 will understand that. They will measure risk. They will calculate the cost of failure. They will tie reliability to revenue protection. They will reward teams for preventing incidents, not just reacting to them. And they will stop treating maintenance like a luxury. Over time, the market may begin to price resilience more directly. Reliable companies could have lower insurance costs, better customer retention, stronger enterprise contracts, more investor confidence, lower regulatory risk. That changes the conversation. Reliability stops being invisible. It becomes measurable business value. And once reliability has value, investment follows. That is how the economics begin to shift. The other force is regulation. Now, regulation can go wrong. It can become paperwork. It can slow innovation. It can reward checkbox compliance instead of real security. But effective regulation does something important. It sets a floor. It says, you cannot be careless with personal data. You cannot ignore basic security. You cannot pretend infrastructure risk is only your problem when millions of people depend on you. By 2050, infrastructure may be treated more like what it already is, critical public dependency. Not always public property, but public dependency. Cloud platforms, payment systems, identity systems, telecom networks, transportation systems, healthcare systems. When these fail, society feels it. That means the rules have to mature, not to punish innovation, but to make sure the minimum standard is high enough for the world we actually live in. Good regulation sets the floor. Competition and engineering excellence raise the ceiling. Now, I do not want this episode to sound like a fantasy, because 2050 will not be perfect. Systems will still fail. The difference is what failure looks like. The failures of 2050 may be less about one server going down and more about complexity. Billions of devices, automated systems making decisions, AI-generated code, supply chains that stretch across countries, cloud platforms connected to other cloud platforms, security threats that adapt faster than today's teams can imagine. And the geopolitical layer may get harder too. Infrastructure is power. Countries know that. Companies know that. Attackers know that. The internet was built to connect, but politics often pushes systems to separate. Data localization, national cloud requirements, technology restrictions, supply chain controls, that creates fragmentation. So the future may be more resilient technically, but more complicated politically. And there is an environmental question too. Resilience often requires redundancy. More data centers, more replication, more compute, more cooling, more power. If we build resilience without efficiency, we solve one problem by worsening another. So the future we want has to be resilient and sustainable, secure and open, automated and accountable, global and respectful of local laws. That is not easy. But easy was never the point. When this season started, we were asking a practical question. How do you build infrastructure that works? And each episode gave us one piece of the answer. Multi-cloud taught us not to concentrate risk in one place. Chaos engineering taught us to test failure before the real world does. Distributed systems taught us that scale requires coordination. Self-healing systems taught us that recovery can be designed. Infrastructure as code taught us that manual changes are not a strategy. Maintenance excellence taught us that reliability is built over decades. Open source taught us that shared foundations can be stronger than closed control. Regulation taught us that minimum standards matter. And the economics of resilience taught us that prevention is not just safer. It can be profitable. Put all of that together, and 2050 starts to look less like a fantasy. It starts to look like a roadmap. Not guaranteed, but possible. And that is the point of this finale. The future is not something infrastructure teams simply inherit. It is something they build. Architecture by architecture, deployment by deployment, post-mortem by post-mortem, budget decision by budget decision, standard by standard, choice by choice. So what does infrastructure in 2050 look like? It could be fragile, fragmented, and over-automated. Or it could be resilient, transparent, secure, and built with intention. Both futures are possible. The difference is what we choose now. For engineers, it means designing for failure instead of pretending failure is rare. For companies, it means funding resilience before the disaster. For investors, it means valuing long-term reliability instead of only short-term growth. For regulators, it means setting standards that improve systems instead of creating empty paperwork. And for the rest of us, it means expecting better from the systems we depend on. This has been Season 3 of the Breakdown Economy. We looked at the failures. Then we looked at the patterns. And this season, we looked at how to build something better. Season 4 will be about the infrastructure pioneers, the companies, engineers, and systems already building pieces of that future today. I'm Tony, and remember, the future does not arrive fully formed. It is designed, it is funded, it is tested, it is maintained, it is regulated, it is improved. The future is not written. It is built by people like you.